this out of the way. Okay, so we're going to be looking at 6-3 binomial radical expressions. If you remember, a binomial is basically an expression with kind of like two pieces. So a lot of what we're looking at today is going to have two pieces, but more so, a lot of what we're going to look at to start is really just add in and subtract in radical expressions, since we haven't done that yet, which is kind of weird. I feel like it's weird that the book does multiplication and division before addition and subtraction, but it is what it is. So looking at our notes, it says like radicals are radicals with the same index and same radicands. So like radicals, not only does it have the same index, like they're both square roots or they're both cube roots, but they have to have the same number underneath. So like radicals would be, for example, the square root of 5, the square root of 5, the cube root of 2, the cube root of 2. Like it has to have the same index number and it has to have the same number underneath. So when we say a like radical, when we're adding, we're going to see it has to have both of these things be true. So just kind of looking at these examples, like with like radicals, like if you have 1 radical 2 plus 3 radical 2's, you basically add the numbers on the outside. That would be 4 radical 2. Same idea when you're subtracting. If you have the cube root of 7, that's really 1 cube root of 7 minus 5 cube root of 7. So you just really subtract your coefficients. So 1 minus 5 would be -4 cube root of 7. So it's almost like when you're adding and subtracting like radicals, you almost just kind of ignore what you have. It's like you have 1 of these plus 3 of these, so you have 4 of these. But if you don't, and same idea with variables, like you just add the numbers on the outside, but you keep what's on the inside the same. So when you're adding or subtracting, like you have more restrictions than multiplying and dividing. So let's just look at some more problems outside of this table though. So like, for example, radical 3 plus radical 3, you have 1 of these plus 1 of these, that's 2 radical 3's. But if you have, like, you can't just combine, like one common misconception is a lot of times students will try and add what's underneath the radicals. If you have a different like thing underneath the radical, you can't combine them when you're adding or subtract. Like it's not equal to that. So like if you had radical 2 plus radical 3, you would just keep it like that. Like you can't combine these. I mean, unless you like turn them into decimals. But like you can't combine them as actual radicals. Okay, so let's just look at some actual problems. Maybe I'll have to try some. So the first thing you always, when you're adding or subtraction, you just want to make sure, do you have like radicals? Like in this first example, we have like radicals. We have a square root for both of these, and they both have 5x as the radicand or the number or whatever's underneath. So if you have 3 of these minus 2 of these, well, you're just going to have one of those square roots of 5x. For part B, look at your radical parts. Since those aren't like radicals, like they're both square roots, but you don't have the same radicand or the number underneath. So if you had a question like this, you would just stop. Like there's nothing you can do with adding or subtracting these, like since they don't have like radicals. For part C, even though we have the same thing underneath, be really careful. This is a cube root and this is a 5th root. So you would not be able to combine these. Like, or you wouldn't be able to add or subtract because, so this one, if you want to know why, it's because they don't have like, it's called radicands when it's the number underneath. I guess I shouldn't say not like, I would just say it's different radicands. Right. And this one, it's different index numbers. So that's why you can't add or subtract. So maybe if you guys want to take a look at D, E, and F, see if you can add or subtract them. If you can, do the addition or subtraction if they have like radicals. But like I said, if they have different radicands or different index numbers, I mean, you really can't do anything with it. So you would just kind of stop or circle what you have. Depending on what you're doing, I mean, if you really, really need to combine it, obviously you could just put it in your calculator, get like the decimal equivalent. But if you're trying to keep it in radical form, like you can't force it. So feel free to try these. If you want to send them in the Zoom chat too, I can kind of let you know how you're doing. Yeah, you could just leave it blank. I mean, technically, like if you were actually working out a problem and you got something like that, Brooklyn, you could like, that would be your answer. You would just circle that. If you want, you can write why you can't do it. Like I said, I mean, but basically, if you can't do it, I mean, oh, I was looking at the wrong. Oh, yeah, my bad. I was looking at the wrong letter. I thought E was the first one. So Leah, sorry, you were right on that one. You sent me. My bad. I thought that was like the first one you sent me. That's my bad. Yeah, no wonder you're confused. I'm sorry. Aslan, those look good, I believe. All right, just because we're a little bit on a time crunch, I'm going to start going over these. So I apologize though if I am cutting anyone off. But for D, you should see you can't, like if you're not careful, like a lot of times you'll like, I mean, they're honestly a lot of these questions they're trying to trick you, like but you do want to be on the lookout. But usually when you're actually doing problems, it doesn't come up a ton. I mean, unless they're specifically just trying to give you a question to trick you, I guess. But this one, since they have different index numbers, like you have a square root and a cube root, you can't do it. So if you want to put, you could say that they have different indexes. That's why you can't add or subtract. But if you were actually doing a problem, like you would just stop. Like that would be your answer. For E, you do have like radicals, like you have the square root of xy and the square root of xy. So when you add these together, your radical part doesn't change. But you basically add your coefficients or the numbers in front. So 3x plus 4x would be 7x. And there's nothing, I mean, really do from there. Same with F, you do have like the same index and the same radicand, like so the same like radical and the same stuff underneath. So 17 minus 15 would be 2, and then you still have a fifth root of 3x squared. So when you're adding or subtracting, it like as long as you're able to do it, like your radical part doesn't change at all. You basically just add or subtract what's in front. So it's actually, I mean, like sometimes you have to do some simplifying to get here, we'll see. But like when you're actually getting into your actual addition and subtraction part, when you can do it, it's pretty easy. But sometimes, and a lot of times actually, you might have radicals. You might have something that are like radicals, but you can't see them until you simplify. So for example, yeah.
Wasn't the other one supposed to be negative?
For which one?
The one you just got finished with.
For F? No, because it's 17 minus 15, so that should be positive too.
Oh.
But I mean, like, it's a good question. Just to make sure, because I make mistakes. Make sure my chat's okay. So like, for example, sometimes in these problems, they might be like radicals, but you can't see it until you simplify. So for example, I mean, you could, like I said, if you prefer to do factor trees, or if you want to, these are square roots, so you could try and pull out a perfect square. Like this would be the square root of 4 times the square root of 3. So that would just be 2 radical 3. This would be the square root of 25 times 3. So that would be 5 radical 3. And then this doesn't simplify. But notice, like, once I simplify these radicals, now they're all like radicals. Because at first you might be like, well, you can't add these together. They don't have like radicals. But if you can simplify, you want to make sure it's in simplified form. So if it's possible to simplify, because now we can actually add and subtract these together. So, and just keep in mind, if you don't have a number in front, remember this is 1 square root of 3. So if you did this, you would have 2 plus 5, that's 7. Minus 1, that would be 6, radical 3. So you always want to check, can you simplify your radicals? Because if you can simplify, a lot of times you can combine some things.
So the one is, oh, never mind.
Yeah, and just let me know if you have any questions. For part B, we have a bunch of cube roots. So like I said, you could pull out perfect cubes, or if you prefer to do a factor tree, like I said, I don't care. However you simplify your radicals, if you have your own kind of process, you do like whatever you're doing. If you're able to simplify your radicals, I don't care how you do it. So like on your test, I mean, unless you're just using like, if you're Googling what is this radical simplified, I don't like, I mean, I want you to be able to actually do it, but so I guess I care how you do it, but I don't care which way you do it as long as it's you doing it. But the perfect cube that goes into the 250 is 125. So that would be 5 cube root of 2. 54, you could pull out a cube root of 27. Oh, sorry, that should be a 2, and this should be a cube root. So that would be plus 3 cube root of 2. And then this one, you could pull out a cube root of 8. So this would actually be a minus 2 cube root of 2. I know I'm kind of doing these a little bit quick, but if you're not seeing how I'm simplifying these either. And like I said, if you want to do a factor tree, you could also just kind of do like a factor tree. Just remember, if it's a cube root, you're circling groups of 3, and those pull to the outside. But now you notice we do have like radicals for actually all pieces. So 5 plus 3 is 8. Minus 2 would also be 6, but then it would be the cube root of 2. One thing that didn't come up, just FYI, if you had a situation like this, like if you had something like where only a couple of the parts were like terms, just combine the things that are like terms. So like this would just be 4 cube root of 2, and then you just keep this part separate. So like if you can't combine, if you can only combine part of it, just combine the parts that combine, and then just leave the like extra parts separate, if that makes sense. But just because like in all these problems so far, like we've got the same radical for like each part. Sometimes you might get some that are the same, some that aren't. So basically with addition and subtraction, you want to just make sure first off you simplify your radical if it's not simplified as much as it can. But then once you've got it simplified, if you have the same type of like radical and the same number underneath, just add them together by like basically adding your coefficients, but your radical part stays the same. Like you don't mess with anything with your radical when you're adding or subtracting. So that's kind of how addition and subtraction works. So it's very different than multiplication and division, where multiplication and division, you just multiply what's underneath. You don't really care what it is. So definitely a big difference between the two the different operations here. The next kind of big part in this section is multiplying or foiling when we have binomial radical expressions. Kind of see how we're doing. Okay, and this is from 6.4, so we. Okay, so when you're foiling, let me just kind of do a couple. There's a couple tips. So when you foil, like, I mean, 3 times 2 would be 6. When you multiply this, you just multiply the outside number. So 3 times 4 would be 12 radical 5. when you multiply this second part, 2 radical 5 times 2 would just be 4 radical 5. But for this last part, when you multiply like 2 radical 5 times 4 radical 5, multiply the outside number, so that would be 8. And when you multiply these, radical 5 times radical 5, if you remember, is 5. Like that would be the square root of 25 if you multiply to get together. So I don't know. I wish I need to say this better, but you can kind of do this in your head. Multiply the outside number, get your 8, multiply your radical part. That would just, when it's the same thing times the same thing, that's just going to be a 5. So 8 times 5 would be 40. So, and then if you combine like terms, this would just, well, you can combine the 6 and the 40, that would be 46. Then if you combine your radical part, 12 radical 5 plus 4 radical 5 would be 16 radical 5. So it's not anything crazy going on here, but the one thing I need to maybe explain better is like when you multiply this like radical part by this radical part, you should be able to kind of do that almost in your head. I mean, maybe you'll have to write some things on the side. Especially, it really only works out nicely if it's the same radical. Like if you had a radical 3 and a radical 2, it's not going to work out super nice. But when it's like the same radical, basically your radical just goes away. So let's look at another one. So for B, if you FOIL this, I mean, 3 times 5 is 15. 3 times radical 7 would just be 3 radical 7. Negative, because that's a minus, so negative radical 7 times 5 would be minus 5 radical 7. So for this last part, I mean, there's not as much going on, but so radical 7 times radical 7 is just 7. Like anytime you take a radical times itself, well square roots, it's remember if it's a cube root, you actually need 3. But all these are square roots, but technically if it's not a square root. But when you multiply a square root times itself, you get what's underneath. Technically, you need an extra one, dependent, like for each degree though. So radical 7 times radical 7 would just be 7. And since it's negative, it would be minus 7. So if you combine your like terms, 15 minus 7 would be 8. And then 3 radical 7 minus 5 radical 7 would be negative 2 radical 7. So how about you guys try C or D? See if you can do these. I wish there was one like A, but oh well. Like none of these have like a coefficient with the radical, but oh well. So if you want to give these a try, see if you can do these. And it looks like, yeah, we're gonna get through these notes. Okay. Oh, I should probably pause since anyone's ready. Forget. Okay. So like if you FOIL out this one, I mean 6 times 6 is 36. 6 times radical 12 would just be 6 radical 12. And if you do the second part, negative radical 12 times 6 would be minus 6 radical 12. So I mean that just cancels. And then negative radical 12 times radical 12 would just be minus 12. So I mean, since you're not going to have a radical part, so then 36 minus 12 would just be 24. We're going to see this is actually called a conjugate when you have basically the same thing, but just opposite signs. You're going to notice basically your radical part goes away. This is called a conjugate. We're going to see you can use, if you remember, we talked about rationalizing the denominator, like in the last section. You can use a conjugate to rationalize if you had like a binomial on the bottom of a fraction, we're going to see. So kind of building on a little bit of what we saw in 6.2 about rationalizing a denominator. But similar idea for D, if you multiply this out, you'd have 9 minus 3 radical 8. And then for your second part, you would have plus 3 radical 8 and then minus 8. So So if you notice, here, I'll just kind of go to this section, but if you notice you have the same exact thing, but just opposite signs, like one of them has a plus, one of them has a minus, but everything else is the same. Basically, you can save a little bit of time. Your middle two terms will cancel. So basically, if you notice it's one of these conjugates, you really just got to multiply the first two things and the last two things. You could kind of skip your two things. So that, because it's based on this conjugate. So if you kind of notice, this is kind of what I was just trying to say. If when you multiply something like in this form, the result's going to always be a rational number. So in this example, so this is how you can rationalize, or if you want to get rid of a radical on the bottom where it's not just a single term, like we saw in 6.2. So if our denominator is this, we multiply by the conjugate. So it's the same thing, just switch the sign. So you would just multiply the bottom by this and the top by this. So the top you just FOIL. So I mean, that would just be 10 minus 5 radical 3. And there's really nothing we can do with it from there. For the bottom, like I said, if you want to save a little bit of time, I mean, you could FOIL it out, but here's how I would do it. Like, so you just multiply the first two things, so that would be 4, and you multiply the last two things, so that would be minus 3, or it would just be 1. So it would be 4 minus 3. I mean, you could FOIL it out if you don't believe, but when you have a conjugate, if you FOIL it out, you would just have 4 minus 2 radical 3 plus 2 radical 3 minus 3. Like you're always, when you have a conjugate, like your radical parts are always going to cancel out. So you can almost just kind of skip those steps, basically just multiply your first thing and the first thing, the last thing and the last thing together. But this would be our answer. I mean, obviously, if you divide by 1, I mean, that's just this though. So I guess technically you could divide it or simplify it. So if you have a question like this, and they want you to rationalize your denominator, you're going to multiply by the conjugate. So anytime you're trying, like, so we, in those other rationalizing problems, you only had like a single number on the bottom. If not, you got to multiply by the conjugate. So we're a little bit low on time, so I don't think I'm going to work out both of these. But basically, to get rid of your radical on the bottom in these, you would just multiply by 3 plus the square root of 5. Not right, same number. Like on this, and in this problem, you would multiply by the conjugate, so that would be. So I mean, like for this one, if you FOILed it out really quick, I mean, you would just have 6 radical 7 plus 2 radical 35 on top if you FOILed this out. Then on your bottom, I mean, wait a minute, I wrote this wrong. Sorry, this should have been a radical 3. Shoot. So sorry, that would have been 2 radical 21 plus 2 radical 35, my bad. Yeah, just make sure, yeah, because I wrote it wrong at first. But then on the bottom, remember, you just multiply your first part and your first part, so that would be 3. Your second part and your second part, that would just be minus 5. So really this would be negative 2. I mean, you could FOIL it out, I mean, but you're going to notice, like when you multiply by the conjugate, it just cancels it out. Yeah, I'm sorry, Brooklyn. I see the comment. Yeah, that was my bad though. And then the only thing, if you want, you could divide this by negative 2, like divide each part by negative 2. I'll just write it below. But you could, so you could write this as like negative 1 square root of 21 minus 1 square root of 35. Basically, if you divide both of these by negative 2. So technically, that might be a little bit more simplified. So, and I'll put up this one if you want to see for B, but it basically would be the same thing. You're going to have some X's on top and stuff, but I don't think it's going to be anything crazy. Let me look at my key because we are basically out of time. Glance, it doesn't look too crazy. I'll make sure one thing I did finally upload the videos of 6.2 today. I'll make sure I upload the video for this today so you have it for tomorrow. Let me stop sharing and recording. But one thing I'll